All right, let's look at graph of cosine. Make a graph of the cosine function by first completing the table. So we're going to choose angles that we can find easily on the unit circle. All right, and just like we did for the sine function, we're going to pick kind of these nice values. They're kind of like equally spaced to give us a good idea of what it's going to look like. And I know for some kind of arbitrary angle that I draw in standard position on the unit circle, called theta, that this point where the terminal side of the angle intersects the unit circle will have cosine theta, sine theta for its coordinates. So that means that if we're going to try to fill in these cosine values, so like what are the output of my function f of theta equals cosine theta, the outputs are just going to be the x coordinates on the unit circle at that angle. Okay, so let's fill it in. So what would these angles be called? So we're going to start at 0, pi over 4, pi over 2, and then 3 pi over 4, and pi gets us halfway around. 5 pi over 4 gets us into that third quadrant, then 3 pi over 2, and then let's see, 7 pi over 4, and then again, if we want to sneak in 2 pi here just to see that it does get us back, we can do that. So let's think about what the x coordinates are at these different points. Sometimes we just think about what is going on in that first quadrant, and then everything else is just a reflection. So that can be a nice way to do it. So this point here is 1, 0, root 2 over 2, root 2 over 2 at pi over 4, and then the coordinates for the angle pi over 2 are 0, 1. Okay, so what does that tell me for my first 3 entries in this table? Well, when the input is 0, then the output is 1 for my cosine function. So again, this is just saying cosine of 0 equals 1. And notice that these are just in radians. And we most often work in radians. Sometimes we work in degrees, but it's kind of our default. So here's my in and my out. Okay, so if my input is pi over 4, my output for the cosine function is just that x coordinate, so root 2 over 2. And then at pi over 2, my x coordinate is 0. All right, what about at 3 pi over 4? Now I'm just reflecting over, and I'm where x's are negative, so negative root 2 over 2. At pi, I'm at negative 1. I'm the farthest out that I can be to the left. At 5 pi over 4, I'm still at negative root 2 over 2, because I'm in quadrant 3 here, where x coordinates are negative. At 3 pi over 2, I'm back on that y-axis, so my x coordinate on the unit circle is 0. 7 pi over 4, I'm at root 2 over 2 for cosine's output, and at 2 pi, I'm just back coterminal with the angle 0 radians, and so I just have an output of 1. So again, that gets us back, and then we would be repeating that same path, right? So like we just did this path, and then if we go more, that's just going to fill out more of our graph, but it's going to have that same pattern, and so we're just going to be repeating. Okay, so we want to draw in our axes, and right now we can just kind of draw them wherever, but as these graphs get more complicated with transformations, then we'll just be a little bit more careful about, how we draw them. It's good to start out with a pencil and all that, so you get used to drawing them. Okay, so we've got negative 1 and 1, and then I'm going to draw those 4 ticks and end at 2 pi, and then halfway there will be pi, and then halfway between 0 and pi is pi over 2, and then 3 pi over 2. Okay, and then if 4 ticks make 2 pi, then 4 more ticks should make 4 pi. That will give me 2 full periods. That's kind of what's required. I can go, the other way if I want to kind of look at what it's going to look on the other side. I'm going to label my horizontal axis theta, since that's what our input value is here, our input variable, and then my y-axis as y. All right, I might be ready now. So just as before, root 2 over 2 is approximately 0.7, so that'll get us there. Okay, so just using our table now, I'm going to go ahead and plot. So for this one, when I plug in 0, I get at 1. So I start out up top. Cosine of pi over 4 is 0.7, so I just kind of approximate where that is. Cosine of pi over 2 is 0. Cosine of 3 pi over 4 is negative 0.7, and cosine of pi is negative 1. So I get this nice kind of little snaky shape there. On the other side of pi, here I go. So cosine of 5 pi over 4, about negative 0.7. Cosine of 3 pi over 2 is 0. Cosine of 7 pi over 4, I'm back at root 2 over 2, or about 0.7. Cosine of 2 pi is 1. And so again, this is one trip around the unit circle, kind of going in that forward direction. Any other trips are just going to help me populate my graph out to the left or to the right of this first period that I've drawn. So I'm going to go ahead and draw it. So what this shape is kind of like a bowl or a vase that's, kind of white at the top and then comes down like that. So that is kind of what we want to think of as this main shape of the cosine function, and I can draw another one. Now, if I draw another one, I don't need all these little points, right? These kind of every other point is really enough because those points in the middle, like this point here, really just gives me the shape. Once I know the shape, then I can just draw it in. Okay, so I know the bowl starts and ends at the top, and then it's going to have the bottom halfway. It's going to hit that midline in the middle here, in this case our x-axis, halfway between the top and the bottom. And so again, once you know the shape and you're feeling more confident, you can kind of fill it in like that. Sometimes an eraser is good to have around when you're first learning, or when you're not first learning, even when you've done it a lot of times. There we go. And then we can keep that going. So let's go to the left. So if I'm starting at the 0, 1, I could also populate the graph going to the left. So if I said, well, what about negative pi over 2? Okay, that would be going this way. All right, what is my x-coordinate there on the unit circle is 0. Okay, and so I would get, kind of this shape where I'm kind of looking at the bowl next to it. Okay, at the ends of these graphs, we want to draw arrows because we're showing that the graph continues on forever. All right, let's answer some questions. What is the domain of the cosine function? Again, if we want to label our graph, this is f of theta is cosine of theta, and the domain is all real numbers. The range is, well, the lowest it can go is -1, the highest it can go is 1. Is this an even or an odd function? Well, I'm seeing it's reflective, it has reflective symmetry across the y-axis, so this is even. So what I know is that cosine of negative theta is cosine of theta. All right, so those are equivalent. And what is the period? Well, I can see that the period is 2 pi. That's one trip around the unit circle. And then everything after that will just be following that same path, but finding coterminal angles. And so it just can give me more of the graph either this way or this way. So I can kind of think of that piece as a stamp, and then I'm just stamping it along the axis, horizontal axis, going left to the left and right. So in this case, my period is 2 pi for cosine.